Okay, hi guys, welcome to my YouTube channel. And based on recommendation, we have our first topic for today, and this is differential calculus. Okay, I know you might be wondering what's the sense of having differential calculus, what is differential calculus all about, but I am going to be focusing on the math. Let's leave the physics, let's leave the application alone for now. So I'm going to be looking at the math alone. So what is differential calculus? To make you understand this better, let's start from coordinate geometry. You remember that if we have Cartesian coordinates, we say in two dimension, y and the x axis, and I have a straight line, let's say just a straight line like this. And if I'm interested in finding the slope of this straight line, so let's call this straight line maybe a function, it's a particular function of x. So it's a function, but it is a linear function. We know that it's a linear function because it gives us a straight line. So we can, okay, the slope of this function, this straight line, this linear function, can be determined by obtaining the angle which this straight line makes with the horizontal. So we can have a horizontal line, let's have it this way, and another one like this. So we have a triangle. The angle here, once we know this angle here, we can find the slope. The slope is just the tangent of the angle this line is making with the horizontal. So this gives us a right angle triangle. It gives us a right angle triangle. And from this point here, I can call this point, let's call this point A, and let's call this point B. So we can extend this downward. This is the initial distance, that's the x1, and at this other point here we have x2, that's the horizontal distance x1 and x2, and tracing this to the vertical axis we have y1, and for the other guy here we have y2. So we know that if we are to find the tangent of this angle, then definitely we need the opposite angle, because this is the right angle triangle. We need the adjacent, we need the opposite side rather, and we need the adjacent side. So the opposite side here is going to be, if you look at it very well, we have this to be y2 minus y1, and we have the distance from here to here. Distance from here to here to be x2 minus x1. So with this we can find the tangent of this angle. So the slope of line AB is actually going to be tangent of theta, and that is y2 minus y1 divided by x2 minus x1. So we know this. I want to believe we all know this. Okay, so this is the slope of this line. Very easy and straightforward. So where does differential calculus comes in? Okay, let's assume we want to find the slope of a curve. Let's say it's something of this nature. Let's say we have this. Let's say let's draw another line. This is x-axis, and let's say I have a curve. So I have a curve of this nature. This is not a straight line, and let's say this curve is also a function that depends on x. Okay, to find the slope of this, you can't actually go through this. This is not a straight line, and because it is not a straight line, we need to introduce a straight line. Okay, back to this figure here. We have that the slope on this line AB, it is the same on every point. If I pick another line, let's say I pick P here and I pick Q here, then if I have a right angle triangle here, the slope here is the same as the slope I have measured. If the answer, the value I obtain here is 5, I expect this slope here to also be 5. So the slope on the straight line, and if you pick any 2 points on the straight line, the slope will always be the same. But for a curve, if slope is different, as you move along the line, we expect the slope to be different, in the sense that, look at this, at this point the slope here is different, at this point the slope is different, at this point the slope is different, at this point it is different. So when you're talking about slope on a curve, you are talking about the slope at a particular point on that curve, because the slope on that curve is not the same. It's not the same, and that is where differential calculus comes in. So I'm going to be doing that now, just a minute. So we need to obtain the slope of this curve, but we know this curve is not a straight line, and we can't use the formula y2 minus y1 divided by x2 minus x1 to find the slope. So how do we find the slope of this function? Okay, I mentioned earlier that we will need to introduce a straight line, so we have to bring in a straight line that touches this curve at just one point, because whenever you are finding the slope of a curve, then you are finding the slope at a particular point, because the slope is different along the curve. So let's assume we're interested in finding the slope at this point. So at this point, I can introduce a straight line that touches this guy at just that point. You might be drawing. I think, okay, so this straight line is called the tangent line. So the tangent line is a straight line that touches the curve at one point. Although we could have introduced the secant line, but I prefer to use tangent line. The secant line touches the curve at 2 points. Okay, so moving on, we have that I can decide to then draw my right angle triangle on this. Let me just pick a big one. So I have this. So at this point here, I have this to be x1. And at this point here, I have this to be x2. And tracing this to this side, I have this to be y1. And at this point here, I have this to be y2. Okay, so this is actually x2 minus x1, which I will call delta x. That is a change in x. And from here to here, I have this to be delta y, which is y2 minus y1. So it's still the same thing. Obviously, you can have an angle here. The measure of the tan of this angle is also the measure of the slope. If I find the tangent of this angle, I also find the slope. So I know that the slope of this function of f of x, I expect it to be tangent of theta, which is the same thing as delta y divided by delta x, which is y2 minus y1 divided by x2 minus x1. Now that we have this, the next thing is to look at this. Okay, so with this, we can see from the diagram that delta x is x2 minus x1. So this only implies that our x1, or should I say x2, is actually x1 plus delta x. That's by making x2 the subject of the formula. Okay, and the slope is now the same thing as, now I want to deal with this. This is going to be delta y over delta x, and that is, so with y2, we know that y2 also, let me write this here, also y2 is y1 plus delta y. So I'll just make y2 the subject of the formula. So we are going to have that y2, anyway, see y2, I can replace it with y1 plus delta y. So that means y1 plus delta y minus y1 divided by x2 minus x1. Let's leave it as delta x. Okay, but looking at this tangent line, you will agree with me that the point here is actually a short distance. x1, the distance between x1 to x2 should be very short, but because I want it to be obvious, that is why I have introduced a triangle that is looking way too big. But as a matter of fact, the distance between x1 and x2 is very, very small, because I'm just interested in the point here. I'm interested here. That is, x1 could have been here and x2 could have been here. Just a short distance. So that means the difference between these two guys should actually be approximately 0, if not 0. So we can say that if we take the limit of these two, I'll assume you know what limit is. Okay, let's just take this. No, if you don't, I need to record another video on limits. So taking the limit on both sides as delta x approaches 0. As delta x approaches 0. So we are going to have the slope to actually leave a lim delta y over delta x as delta x approaches 0 is equal to lim y1 plus delta y minus y1 over delta x as delta x approaches 0. Okay, and this guy here, this left hand side, this left hand side I have here, is the same thing as finding the y dx. The same thing as differentiating this function, finding the slope of this function. So when you take the limit by definition, so the definition, probably I should have explained that earlier, but maybe I'll have to record video on limits. So by definition, we know that the limit of this, as this tends to 0, is actually dy dx. So doing this, you have actually found dy dx. So this means that the slope is actually, so this means that dy dx is actually the limits of y1 plus delta y minus y1 divided by delta x as delta x tends to 0. So this is the slope, and the slope of this function can be found. The summary of it all is that for you to find the slope of this function, you actually need to differentiate this function. So if you differentiate this function, then you have actually gotten the slope. And this value we obtain here is called the first principle of differentiation. So I'm going to be doing something now, which I'd like you guys to pay attention to. So the slope of the function f of x, I forgot to mention, this f of x, we can also say it is the same thing as y of x. Okay, so we use this notation, f prime of x, to denote the slope, or we use dy dx, or in this case y is equals to f of x, so I can say this is d of f of x. Whenever I say y, I'm replacing it with f of x divided by dx. It's actually the limits of, now I know it is y1 plus delta y, but y1 is the same thing as f of x1. So let's say it is f of x1, I just want to assume x1 is the same thing as x, plus delta x minus f of x